Okay guys, Lewis form factor from equation 12.5 or table 12.5. Okay guys, what we will get? Lewis form factor is equal to y. For 20 degree, the given formula is 0.154 minus 0.912 divided by z. Z is the total number of tooth given in 24. Okay guys, okay, after we will after dividing 24, and we will get 0.154 minus this quantity, we will get this. Okay, now we will find out the Lewis factor. This is Lewis form factor, this is only form factor. Okay, form factor is find out by pi multiply y. Okay guys, I already told you pi. After multiplying this, we get this ft. Now force is equals to sigma d cv. This is sigma d and sigma b. We will put the bending strength value. Okay, cv, b is the width, y is the form factor, m is the module. Okay, sigma v bending strength. What is the bending strength value? 200 Newton per mm square. Okay guys, 200 into 0.526, this velocity factor we find out again before, into this b. Okay, this b is here, b we have find out from the way assume. M is the m, this is the m. Okay, this is 10 m b, because the value of b is ranging from 12.5 to 9.5 to 12.5 m. Okay guys, and then we had find out this is the form factor value. Okay, this is the form factor value here. After multiplying it, we get 383.3488 m square module square into 10 to the power 6. Okay guys, and after that, if you have any problem how we got this 10 to the power 6, the unit of this 200 Newton per mm square is what? 10 to the power, I had converted it into the meter square. Okay guys, it's in SI unit guys. Okay, SI unit, like here it is given in 200 Newton per mm square, but I will taking all the system, all the, if you are doing any calculation, then if you have to assume, if you have to not assume, you have to take all the things in the same unit. Okay guys, so I am taking the same unit into 10 to the power 6 Newton per meter square. Okay, after that we will solve this one and we get these things. Okay, now what will happen? Step 4. In step 4, what we will do? We will equal this Ft. What is Ft? Okay guys, driving force or tangential load at pitch line. This is a driving force or tangential force at pitch line. Pitch line equal to F effective force. 383 into 10 to the power m is m module square into 10 to the power 6. Okay guys, 45.96 m, the F effective value. F effective value, however we calculate, this is the F effective value. Okay guys, in step 2. Okay, so after that what happens? We calculate this value. Okay, 1 point after this is m square and this is m. This m will go here and it becomes m cube equal to 45.96 divided by this quantity into 10 to the power 6 also guys. Okay, 10 to the power 6, and it will go here and it will become this m cube, or after m under root cube, cubing both side we get. Okay, and m becomes this. This is the m. We had converted it into the what? In a SI unit, so it will become this value and m becomes this. After that what we'll do? After this is the in meter. Okay, this m is the now is meter. This unit is m. Module value is always d by what is module? Module is equals to m by m is equals to d by t. So it's d is the pitch circle diameter, so it is value is always mm. So I am converting, this is an SI unit, I already converted it in the SI unit. Now it will become SI unit meter, and to convert meter into the mm, I multiply it by the 1000 and we get the 0.00491 into 1000, we get 4.91 mm. Okay, after that, from table 12.13, choose the value of standard m. From the 12.13, okay, we will go 12.13. Okay, we have to go table 12.13. 12.13. Okay, 12.3, 12.2, 12.13, 12.11, 12.13. Okay, here is the standard value of m. Okay guys, I had find out the standard value from the calculation. I had find out 4.91, and here there is no 4.91, so we always take 4.91 is approximate to the 5, so I will take this value. Okay, from this table 12.13, the standard value of m is 5. M is equals to module m is equals to 5 mm. Now, according to the m, calculate the d and find v. Okay, now we have to find out whether it is this module m is verify or not. We have to verify also. Okay guys, we are going to design the spur gear whether it is verified. Verify means whether the module 5 m equal to 5 mm gear will able to withstand the load that we are going to for design. Okay, our specification will meet or not, we will check from this m. Okay, this m will satisfy or not. Okay, to this, first what we'll do, according to m, calculate the d. Okay, again we know that the d is equals to m into z. Okay guys, okay, then we'll find out the v, pitch line velocity. According to v, find cv. Okay, velocity factor. Find f effective. Okay, again we will find out the f effective, cs by cv into pt. Okay guys, now first what we will do, we will find out the d. D is equals to module equal to diameter by number of teeth, that is number of teeth 24. Okay, 5 into 24, it has given in the question. Okay, 120. Velocity we know that if we have to find out the linear velocity, we have given a omega, that is 1440 revolution in per minute. We have to convert it into the linear velocity by using r omega. V equal to r omega, we know that, we all know that. R equal to d by 2 into 2 pi n. After that, after calculation, we will find out the velocity 9.047. We assume the v equal to 25 again, but now the velocity, actual velocity will be this. Actual velocity will be this or not, we will verify again. Okay guys, so now from equation 12.19b, velocity ratio cv for approximately equal to 9 meter per second will be this. Okay, from 12.19, okay, what is 12.19? We have to go Barth formula. Okay guys, where is it? Okay, now for we had find out the line velocity up to 8 meter per second. It will not suitable because it is our velocity is greater than 8, so we will use this formula. Okay, now we will find out the velocity factor from this 12.19b. Okay guys, why we are using, because this velocity is 9 point something. Okay, so it is satisfy, it is less than up to 13 means we can use for 9 m the 9 meter per second is greater than this value 8 meter per second, so we will use this one because the value is less than 13 meter per second, so we will use this cv formula. Okay, to find out the velocity factor. By this formula we find out the velocity factor, and velocity we got the velocity factor this. Okay, after velocity factor, f effective, cs service factor we already taken as a 1.25 divided by cv equal to 0.3372 into 19.34 divided by, okay guys, what, 5 into in the if you go to the step sorry, if you go to the step first 19.345 m is a module is in the mm. Okay, so we use this step 1 formula. Step 1 we get the pt value in step 1, so 19, this is the from the step 1 we find out the pt equal to 19.34 divided by m. Now we have a value of 5 m. 5 into 10 to the power minus 3 means it is in 5 mm, so I am converting it into the what in Newton in SI unit, okay, in meter. So we will get this value 14,300 Newton. This is 14,338.67 Newton. This is 14 kilonewton. Okay, we can say that approximately equal to 14 kilonewton. Now we will go to the driving force. What is Ft? I already told you guys, Ft is a driving force or tangential load at a pitch line. Okay, from the Lewis formula, what will sigma b bending strength into cb velocity factor, b is equals to width of the tooth, y is the form factor, m is equals to module. Okay, 200 into 10 to the power 6 into 1.25 into 10 into 10 into 5 into 10 to the power 3 means this is module. We had taken b as a 10 m, so equal to 10 into 5 into 10 to the power minus what we will do minus 3. Okay, same thing, 10 m value is 5. We are converting this m value into 10 to the power in meter, so I am dividing it by the 10 to the power 3. I'm going to minus 3, using minus 3 because the denominator one, if you use a law of indices, you know the, then if it goes to the above numerator, it will become 10 to the power minus 3. Okay, into 0.364, this is a form factor, m is equals to again 5 into 5 is the module mm, we are converting mm into meter. So we get this 27,775. Okay, now what we will do? Now we will check whether this Ft is greater than F effective or not. The driving force, the tangential load should be always greater than driving force, otherwise, okay, 20 Ft is equals to what? 22,775 greater than or equal to 14,338. So let's move to wear strength. Okay, we have to find out next wear strength, guys. If it does not satisfy, what we will do? If Ft less than F effective does not satisfy, is not valid, it means that Ft less than F effective. If it does not equals to Ft greater than, if it does not equals to this, it means that F effective is greater than Ft. Okay, greater than F effective greater than Ft. Okay, so the gear cannot load, cannot bear the bear the force the gear has to be bear. Okay, what does it mean? If Ft does not greater than F effective, it means that we can conclude that the gear cannot bear the load that it has to be bear, and we are designing to bear this amount of load, but it does not bear, it cannot withstand that amount of load. Okay, so we have to change. What we have to do? Change. If you have to make the gear more strong. How you will make more strong? By increasing the width space of the gear, if you increase the width of the gear, width of tooth space of the gear, then its area will increase. It means that it can hold, it can bear or withstand a very high larger than previous one, withstand the load larger than previous one. So guys, in the next lecture we will talk about how to calculate the wear strength. Okay, thank you all.